All right, so I think we should be live streaming now. Let me copy the streaming link and send this out to Twitter. LinkedIn.
Oh, weird. So I went, did you schedule it to, oh, I see.
Right,
It was delayed.
Yeah, it's got a little delay on it. So hopefully.
I couldn't figure out how to mute it, but I got it now that it's playing. So we're good.
Okay, so it looks like it's working on that side, KJ. All right. We'll give people a few minutes to trickle in, but I suppose maybe we could do a quick round of introductions. We'll just go one by one, give people some time to filter in. KJ, let us know if people are starting to show up. Ben Blazek, I'm at University of Chicago, Argonne National Laboratory. And we have with us here Ari and KJ. Do you want to introduce yourselves?
Sure. So hi, everyone. My name is Ari. I work with Ben and KJ and Logan at Globus Labs at the University of Chicago. I'm also joint appointee at Argonne National Lab. And my background and specialties is in machine learning and AI.
Yeah, I'm KJ. I work at Globus Labs at the University of Chicago with Ben and Ari and Logan. And I also have a joint appointment at Argonne. Yeah, my background is in artificial intelligence and software engineering. And yeah, that's it.
And we are lucky enough to have Logan Ward speaking with us today about a code template that he's been working on for helping researchers bootstrap their AI projects. And I think some of us have seen Logan in the past give talks about how things are organized in his repositories, and I think that this will hopefully help a lot of people get started with AI projects. So I don't know, Logan, if you want to just kind of briefly introduce yourself and then head in however you want. We'll just kind of pipe up with questions.
Yeah, sounds great. So I'm Logan Ward. I'm also a assistant scientist at Argonne. I happily work with KJ, Ari, and Ben, and I've been at the University of Chicago, Argonne since I finished my PhD around in 2017. So most of the work I do nowadays involves some flavor of AI plus materials engineering plus high performance computing. And like many other scientists at a national lab, or many scientists in general, I'm spread over a lot of different fun projects, ranging from, I was working on radiation damage this morning, battery science yesterday. I haven't yet figured out what I'm going to do this afternoon because I've just been thinking about the live stream.
Logan, just to interrupt for a hot second, I think you're a little quiet. Would you mind adjusting your mic?
I'm positioning it closer. Is that helping out a little bit?
Oh, there we go.
Okay, awesome.
Oh, much better. Awesome.
Perfect.
Great. Yeah, so no, I do kind of a lot of different things, and I've been working in computational science more broadly, probably since about 2008 or 2009, I suppose. I had an internship at AFRL, which I'm pointing out my window because it's just down the road here from me in Dayton, where my introduction to computational science was a summer internship and a big old folder of compact documentation for Fortran programming language, which was enough to convince me, surprisingly, that I enjoyed computational science, but also encouraged me to realize I need to get training in software development because the single giant Fortran file just wasn't a good way of doing things. And I actually did some training in how to do this well.
I guess, Logan, before we get into some of the other details, I think you were also a member of the OQMD team at Northwestern. So a lot of people might know you from that work. Do you want to give a quick background on that too?
Sure, yeah. So I worked at Northwestern for my PhD with Chris Wolverton. And one of the things his group has invested a lot of time in are creating large databases of properties calculated from quantum mechanics, more specifically density functional theory. So when I joined the group, we were just starting to do machine learning related work. One of our former PhD students, Bryce Meridig, who incidentally drove to California to start his MBA kind of the week I joined Northwestern. So I briefly crossed over with him there. Kind of broke a lot of ground in our group on the fact that we could use machine learning to avoid doing the kind of costly DFT calculations that made databases such as the OQMD so valuable. And kind of a lot of that has really spurred the kind of work we do nowadays with seeing if we can replace experiments or at least find ways of just generally augmenting. Sorry, I didn't stay too long within your prompt of OQMD, but yeah, that's where we ended up starting out. And Bryce Meridig now, of course, is the Chief Science Officer. I know he's one of the founders.
That's right.
That title hasn't changed, of Citrine Informatics that does a lot of AI for the materials industry.
Yeah, and I think, you and I met 5, 6, 7 years ago now at this point. It's been a while, at a CHIMAT event. So Center for Hierarchical Materials Design. I think we happened to cross paths at a poster and learned that we were both interested in many of the same topics. And it's been great to work with you largely since then, after you finished your PhD there.
Yeah, no, I met you and thought, hey, man, I want that guy's job, or maybe more specifically, I want a job like his, and was glad to find out about the Computational Institute through Ben.
That's amazing. That's so funny.
Yeah, so I think today you were going to show us some detail of this code template. I don't know if you were planning to do just like a walkthrough or slides, but whatever you feel most comfortable with.
Yeah, so I decided, given the nice modern format of a YouTube live stream, that throwing up slide decks would be kind of a poor use of the medium. So what I was going to do today is actually, I have a zip file of all of my PhD work, and I was going to contrast that and point to a bunch of the problems of what made my life difficult as a PhD student, and then kind of walk through the kind of ways I started to work more effectively as a postdoc, and now the kind of more formal ways I've tried to write out a work plan to make it something that, or the kind of lessons learned that I have, or the lessons that I have learned accessible to others. Because as we mentioned here at the beginning, I learned how to do computational science while also teaching myself Fortran 77 and the Vim programming editor, which, not to say that those tools haven't enabled a lot of great science. They're not I think the most effective way of communicating science, or perhaps the clearest way of being able to practice it in a reproducible manner. Not throwing too much shade on Fortran 77, given its prevalence. And yeah, the fact I still run Fortran 77 codes, not ones that I write. But yeah, with that said, we'll see if the share screen works. Oh, could the host enable screen share?
While Ben does that, I just want to say, Logan, I'm so excited for this because your organizational skills are like unparalleled. So I'm very pumped for this, like, to see your process, I guess, to see your process and learn about it. I think will be very helpful.
Sorry. I know you hold that position because my camera is positioned such that it doesn't show the pile of papers around my desk. I was doing taxes this morning too.
Your scientific organization skills are impeccable.
All right, I'm much more comfortable with that claim. All right, so we'll go ahead and get a screen share going. Awesome. So how is my font size? Should I blow this up a little bit more?
Yeah, it's a little bit small.
Okay, I'll share a different window, my smaller one.
I see Magpie. I'm excited.
Yeah, so share the same window again. Give me a second. I can't talk while doing this.
And I think while Logan is figuring this out, we had a conversation, I guess it was maybe a few months back now, about how many of the standard things that you do in an ML or AI project for material science you could put into some kind of template or some kind of process. And I think that, that came up from a few different directions, which was interesting. I think we talked about it, and you said you talked about it with somebody else. And so developing a template for this, I think, will be very helpful. And we'll put the link to the repository that I think Logan will show in the description later.
Yeah, no, absolutely. And indeed, it was a conversation that Ben and I have long had. And then as I teach a class at the University of Chicago, and for their final project, they're asking me how they should organize their work. So I quickly brought together this YouTube, sorry, not YouTube, this GitHub repo. But maybe we'll start from the kind of less ugly part that I wouldn't encourage you to start with. Are you guys all seeing the font size a little more clearly?
Could you
Yeah,
go
that
ahead
looks
and
really
use
good.
a smidge more?
Yeah, I think I can blow. I don't know if that's doing anything with the font size or just the how about
That still
this?
help.
Yeah, I think that
Okay.
helped.
I'll see if I can blow it up slightly. Okay, I can change my fonts, but not the size. All right. Well,
That's okay.
this is why we're doing the test out with a nice internal person with this format. So yeah, so here we are. This is my Magpie folder, which I'll open up. I keep all of my work on in a big folder called code, Java, Magpie. So this is my PhD work condensed into a 6 gig zip file. And what this really is the source code directory to Magpie, or the materials agnostic materials agnostic platform for informatics and exploration. It was a stretched acronym. I had a lot of time on the bus, so I had a good time coming up with this. No. We'll see if I still remember the URL for it. Yep, so this is a Java code I wrote as a PhD student. Basically as a means to help me do my own work. And we made open source. It hasn't, I don't think it's been worked on for a long time. Yeah, my last commit to it looks like about 2 years ago, and it was rather sparse before then. But suffice it to say, I was developing this code, making a lot of changes to it simultaneously with doing projects. So what I did is I just dumped all of my project materials in a nearby folder, so they were co-located nicely with my code. And so what you see here are a variety of different projects, some of which turned into publications, others we just explored with. And you can see here, there's not really a consistent naming system. I did some work for a PhD student named Andrew. Nope, this wasn't the PhD student, Andrew. This was sorry, same name, different Andrew I was thinking of. So in fact, the fact that these things have such simple names to them, like this was work for related to Ann Demmel, who is a colleague at Pacific North or Colorado School of Mines. Mohan was another PhD student. In short, hopefully I'm not convincing you that this was a good organization system. Hopefully I'm going to show you the other way around, because really what I've got into nowadays are just piles of code and input files that I have a hard time making heads or tails of now. And maybe if I look at this script here, which is a run script for Magpie. I did document what it does at the top, and I've got some documentation in between. So I could probably figure out what this project was, but it's very sparse. Being able to pick up this project, of course, 7 years later is more or less impossible, but I would say that even a few months afterwards, this was going to be a very difficult project, even for me, to be able to recreate, much less someone else. So with that in mind, I've kind of gravitated towards using a different approach for being able to keep all of my research organized together. And yeah, so do you guys have any comments on this, or should I start pulling that material out?
Oh, I was just going to mention, oh, sorry, go ahead, Ari.
Oh, I was just going to say this is highly relatable. That's all. Like the folders that have ambiguous short names that could mean many things. Folders called code, very, very relatable.
Yeah, and no versioning system for these individual projects. I did use Git for the source code, but the projects themselves, who knows if I'm looking at the right version. If I changed one very important character in the file that made the science correct, all that's lost to time, I'm afraid.
Mhm.
Yeah, the point I was going to make is that a lot of people are talking about fair data, findable, accessible, interoperable, and reusable. And I think that, what is often lost in that conversation is these other artifacts. So the code, the models, the processes that you use to get that data. And so I think, many people are faced with the same problem where you have a stack of folders that are named in ambiguous ways. You leave that project as you finish your PhD or move on to other things. And it's basically impossible even for you to use, let alone somebody else. So.
No, very well put, Ben. And yeah, that certainly reflects my experience.
Mm-hmm.
Yeah, the other thing about this way of working is because I didn't invest the time along the way to making my work reusable, I ended up having to invest a lot of time afterwards. Like we can take a look at the paper that came out of this Magpie project, and you can see my time tracking app. But we did end up publishing the data in code along with this. If you scroll down to the bottom, where we supplementary info, you can download a zip file that is basically the version of the source code that was used along with the input files and scripts. And I put a bunch of readmes in there to try to help people navigate through it. I grouped all of the scripts from their random folders into ones that were related. So maybe it's more reproducible. I've had people download this file and email me with questions about, which, by the way, I'm always enthusiastic to get questions about the work. So yeah, feel free to email me about any of my papers. But in short, not only the way I was working wasn't conducive, it wasn't reproducible by itself. And it takes a lot of work in order to bring it up to a point that it was even reasonable of being sharing. Now I give a whole nother talk about how after some questions from a colleague, I ended up finding that, well, given these files and data and source code versions, you can't get the exact results that I got in my paper, probably due to random variations in the random number seeds used in the algorithms, but really, who knows? And that's the kind of thing that, as a scientist, keeps me up at night. Okay, that's a lot of an exaggeration, but it's certainly something that I fret about talking on YouTube live about. But it's unfortunately the truth.
Also very relatable.
Yeah, I think you've convinced me that this was probably not the way to arrange your data. And so do you have any suggestions on how to do it now?
All right, well, thanks for the change of subject. I was also just looking at the time and I just spent 15 minutes talking about how not to do something. So we'll go live and I will open up the work that I'm actively was working on yesterday. Let's see if I've got my Jupyter. Yep, here we are. So I'll bump up the font size. So one of the projects I'm working on is a seed project at Argonne, where we're seeking to find new materials to store hydrogen. We're trying to find molecules that you can, without much of an energy penalty, add or remove hydrogen from them. Now, what I've done is I've taken that project and I've grouped it together into a folder. And over this course, I need to keep track of a lot of different things in order to reproduce it. I first need something that captures my computational environment that I use. And as you see in the README file that comes with this directory, I've also learned Markdown in the previous years between now and a PhD student. But I have an environment file that contains every version of the code that I use. And the key libraries I fix, usually to their minor version, to ensure that it's all, I can bring it up and run the same code on a different computer without problems. So that's kind of what the computational environment looks like. And additionally, I'll take my code here and organize it into subdirectories where they're organized by project. So here I've got my search space application where what I'm trying to do is take a list of perhaps 100 billion molecules and find the 1,000 in there that are going to be the most interesting for further study very quickly. So here I go and describe the application that we use to do that. And I also hold on to all of the run files so that you can go through and say, find the exact version of the code that was ran to generate a particular result. So you can see right now I'm going on my GDB 17 search. We can go through and record the actual input files that I used. I've got a log that tracks the project of the execution so that I have all of this organized together. The human effort goes into writing the software. And as I'm writing the software, I'm ensuring I'm doing it in a way that captures kind of all the nuances. Additionally, you saw me flash open a Jupyter notebook. That's really the other key ingredient. When I'm writing a more kind of precise analysis that might have a lot of subtlety to it, I want to ensure that that's captured in a form that I can easily put the code next to something that explains what it does. So here, I am following a process that was actually developed by an intern who's, I think, just now graduating from Johns Hopkins. Forgive me, I don't remember her name, but she had a really cool technique where she took her search space of molecules and tried to cluster them and then pick only one molecule from each cluster. So here you can see I recreate that. I talk through the computational process. Unfortunately, my picture didn't render, but I've got this in a way now that I can go back through my analysis. I have a title that explains what it is I'm supposed to do. I have an abstract that describes how what this notebook does and why. And then I've got the code interleaved with some explanations and some visualizations that show it is working as intended. So here I'm actually doing the clustering. I won't show it to you now because it takes a half hour to run, but you can see I've debugged to ensure, all right, I'm getting a reasonable size of each cluster. Most of them have about 1,000 molecules in them. And I can see in this visualization that indeed I'm breaking down regions of space into areas that are closer to each other. So indeed my code is working. And this has given it to you in a way that you can see the results for yourself. You can reproduce them. You can hopefully understand them without knowing the particularities of the Python underneath. So ideally, this is because I'm doing this while I'm actually engaging on the project, I can just share this notebook out with others. And in fact, I've done that for many other projects. I had a recent paper with the same or a similar group of colleagues at Argonne, where we predicted salvation energies of molecules. And the code, I did the same thing exactly as I was working through it. I was committing it to Jupyter notebooks, organized in subdirectories that contain descriptions of what I'm doing and the code along with the code that actually does it. So I didn't have to do all this separate in order to before publishing the work.
Can I interrupt you with a question, Logan?
Of course.
So what is your process? So these notebooks are beautiful. They're like very clear. You know, me knowing nothing about this, it's easy for me to kind of see the interesting parts of your work. Do you work on them while you're developing your code? Like, I find that one of the hardest things for me is in a machine learning project, you have so much like constant tweaking of the model and like tweaking of the parameters themselves. How does that interact with like when you start working on this notebook? And yeah, like how integrated is that process?
Oh yeah, I try to do it from the beginning.
Okay. So it's like as you're developing the model.
Yep. Before I start, I generally try to break down each notebook to only capture one idea. And I'll make sure that that idea is well formulated enough by writing that abstract up at the top. Like when I was tackling, as an example, when I was tackling this clustering problem, one of the first things I had to do was think through what clustering algorithm am I going to use. So I wrote down what are the constraints that this thing must satisfy. I need to have clusters of different sizes. I need to have it be exceedingly fast. So that all ended up with me picturing k-means. In fact, I need to go fix this because I tried using agglomerative clustering. It wasn't fast enough. So I need to go back and fix my documentation. But yeah, in effect, my kind of policy is to ensure that I don't really try to tackle something that's bigger than what I can understand. If I don't understand, if I can't get a good picture of how I'm going to approach the problem generally, it's time to like sit down and write English instead of Python until I'm at a point where I'm comfortable enough to put pen to paper on it. Sorry, that was too metaphorical. Until I'm starting to actually start writing code.
Gotcha. I think that's a great takeaway.
Yeah, it's just about like keep breaking the problem into smaller bits until you can gradually work your way through. Yeah, and I have a whole other like formal presentation on it that I should record. I was about to pull up my slide deck, but I'm not going to. I do things like always restart and run your cells periodically to ensure that even if Jupyter allows you to tweak code and then run using the currently stored state, it's fantastic for debugging. It can really get you into a world of hurt if you if that results in you deleting the code that's necessary for your current notebook to finish. So I continually like restart and rerun it. And particularly for this example, I made a small data set that I could work from instead of the big one that's going to take a half hour to run. I made sure to keep my problem size small enough that I could do most of the debugging without having to wait hours for kind of results to filter back in. It's another trick I use just to ensure that I can both get the iteration, but keep it in a way that encourages me to keep writing documentation as I go.
Logan, I really like this as a step between something like a traditional scientific paper and a paper that you could almost execute from top to bottom, right? Where all of the figures are reproducible, all of the different components and analyses are swappable. Of course, that's not quite what we've achieved here or you've achieved here, but like it's a nice step towards that. And I know there's a lot of people in the community that are interested in going that way over time.
Yeah, no, I think it'd be very interesting. I'll admit, I'm still a little bit skeptical about whether I can publish a stack of Jupyter notebooks in the same way that's a paper. It's harder to tell a linear story in something that can be spread across many documents where naturally manuscripts are good for that. But no, I share at least optimism that someone would figure out how to do that eventually. And then I can crib off their notes.
And so you've shown this specific couple of cases that you've developed here for the two different cases you've mentioned. Is there something you think if people are trying to get started themselves, how does someone follow this process?
That's a great question. So that's something that I've started to try to be able to provide to people. So this here, what you're looking at is my AI project template that, as I mentioned, I created for some students in a final project that I teach, which another plug, all of the GitHub materials for that or all of the materials from the class are available from this GitHub page. Besides all of the tutorial notebooks, you can get to a link of the lecture recordings from last year and get to my slides in case you want to just borrow slide material for your own purposes. Yeah, just feel free to use any of this, but that's all up as well. But back to the question at hand, where was that? Is it in a different window? Okay. I'll just go back to where I was. Sorry about that. So yeah, the AI project template. What I'm doing here is I'm creating an example for the layout of projects that I tend to use nowadays. and also filling it with enough of this text that you'll be able to see some of the rationale behind it. So effectively, what I've gone through and is ensured that there's a way to describe how we can do the work to fit all of those features we were just talking about in conversation. How do I make sure my work is reproducible? How do I make it publishable in its current form? Some other features we didn't talk about, but how can I make it such that I can engage others on my project with me? And while I'm not completely there in finishing this template, what it does have now is a step-by-step that will at least should get you up through the kinds of stuff we talked about today. They walk you through a Git repository so that you can capture the version control. I kind of use GitHub as my lab notebook, where I can keep track of individual changes I've made, along with some rationale describing why I made them. So I'll walk you through that GitHub repository. It also links out to tutorials for some of the bits of technology you might be unfamiliar with. It tells you how to make the Anaconda environment files so that you can easily run the same computational environment on different computers, which is exceedingly helpful for reproducibility. It talks about how I store my data. One thing we didn't talk about is I always ensure I keep a gold standard copy of the data that is never edited by me. It's in whatever form it was provided at the beginning of the project. But knowing that that's often tedious to work with, I'll keep that cleaned data in a kind of pandas-friendly format nearby it. And I'll also go through a little bit on like what my first notebook for parsing data is, how I build a Jupyter notebook. I have a header, topic sentence, few steps of code, summary. So topic sentence, I need a numerical version of the class column. Conclusion, I've got a numerical value for the class. Hopefully it'll walk you through all the parts of it such that if you don't know pandas, not understanding these intermediate steps won't harm your ability to understand the overall science. So as you can see here, I'm not completely finished. We didn't yet talk to the kind of techniques I use, such as in that Jupyter project I was showing you earlier, where I write a executable file in Python that takes in some command line arguments as inputs to run science, and then saves itself in a specially named directory. I'll eventually write about how to do that and put that up on the GitHub as well. This is another technique that I found to be really helpful for problems that are too big to fit in a Jupyter notebook. In fact, this code here that I'm running has been running for a day and a half. I expect it to run for another 4 or 5 days. So naturally, it's not something I want to ever run again without any purpose.
Yeah.
And as we mentioned earlier, running Jupyter notebooks many times is their primary advantage. So I invested some other time to write code in another way, but I know we're kind of bumping at the end of our 30 minutes. So we can talk about the details on that another time, or now that I've been encouraged by talking about it, I'll try to put in some more work on my AI template to help you out.
Yeah, and I think the other point here is that we'll kind of socialize this repository with the community, and we'll let them know the link, but also that the responsibility doesn't rest only on your shoulders to develop something like this. This is the type of thing that could be broadly useful to the community, having this nice template to start an AI or ML project in science. And so do you think somebody, if they were interested in helping, could start at that repository, make pull requests, add GitHub issues? Is that the flow you'd imagine?
Oh yeah, absolutely. Yeah, forking and pull requests are great, especially if you're already familiar with those kind of tools. But I am on Twitter, and you can complain at me on Twitter, and I will gladly have a conversation with you about it. Okay, I don't mean to belittle anyone. You can have a conversation with me on Twitter. I'm not going to demean you and call your comments complaints. But no, in short, these are the ways that I work. They're not going to be the best for everybody. In fact, One alternative I've had you consider is MLflow, which is very well geared towards running these sort of command line experiments that I do. I found about MLflow after I got very comfortable with working in argparse, which is the Python command line executable library.
Mhm.
So this might have been a better place for me to start, and could be a good place for you to learn if you think, oh yeah, a command line thing that would just keep track of my experiments over time and never delete them unless I tell it to. That sounds like it's the thing for me. In fact, I'll call out to Ben Galuski, who might be another interesting person to talk to for this live stream. He's the one who's kind of turned me in this direction, and I still have yet to take his advice, even though I like it.
Oh man. Logan, real quick before we go, how does it feel having gone from your PhD work to the way that you work now with this new organization?
Oh, much better. It's so much more satisfying to come back to a project and be able to see, oh, I actually understand what is going on here. That's one of the big advantages. In fact, there's a project I've been working on for 4 years, and I'm still working on the paper. Sorry, Andre Schleifer, if you see this. We've been working on this project together. And the fact that we've recorded it in this way has made it possible for me to procrastinate so badly on this project and yet still have a path through to publication. So yeah, it feels good. It's easy to share my work and converse with it for others. And I think Markdown-based documents look pretty. So yeah, what else more could you want?
I think one of the other important things that you mentioned, and I hadn't thought about this before, but was the connection between someone like you and, say, the experimentalists within a given project. And you can basically hand them these notebooks, and they don't need to understand all of the code, but they can see at the end, here's the great molecules that we found. And so it really starts to bridge some of that gap between the people who are doing the ML and simulation and the people who might be doing experimental work or things like that.
Mm-hmm. Yeah, and it's not just experimentalists. Actually, one thing that Stopping Power project I showed you, one thing that really encouraged me to refine my Jupyter notebooks is I know I really knew very little about radiation damage at the beginning of the project. So if I had a technical question about whether I was doing something right, I could just send someone the notebook, and they can, even if they don't understand Python, could hopefully at least tell me if my algorithm seemed correct. Bug hunting would, of course, still be in my under my supervision, since if they're not familiar with the Python part, but hey, get you at least halfway. So no, that is a very good point, Ben. And I was meaning just to say that I've actually used that in my projects.
Yeah, very cool. So KJ, I know you've been monitoring the live stream. I don't know if we have any questions that came up, or this was our first live stream. So we put the link out at like 1 o'clock on the dot. So we may be more of a asynchronous type of question. Dave?
Yeah, nothing in the chat yet. But I just want to say I'm so excited that you have this repo out, Logan, and I'm definitely going to use that in the future, because it's so frustrating for me when I find a notebook or like a Medium article with code and then no explanation. And so it's nice that it's kind of just baked into this whole process.
Mm-hmm. Yeah, a lot of me developing this is from the same core when I'm handed code, and it's going to take me weeks to figure this out.
Yeah.
And it's the worst when it's your own code and it still takes you weeks to figure out. You remember that you did it several years ago, but it's just totally flown away.
True.
Unfortunately so.
Well, good. Thank you, Logan, for being our first guest here and for trying this out with us and really walking us through this great new repository and your workflow. And I think there are probably many other conversations we could have in the future, but this was a good one to start with.
No, and I'd be glad to. Always fun to chat with you guys. And thanks for inviting me on.
Thanks for coming. This was awesome, Logan.
Thank you.
Yep. All right. Bye, everybody.
Bye all.
Bye.